I work at Wix. Wix is a web-based platform that lets small, medium businesses to create a stunning website and manage their business in one place for free. We have over 130 million users, and to support this, we have over 800 microservices. And we are doing TDD, so it's quite a challenge. My name is Maxim Novak. I work at Wix for over 4 years, and most of my time at Wix, I wrote infrastructure services. It means it's microservices that take care of cross-cutting concerns that the product teams use. For example, authentication, authorization, emails, SMS, URL shortening, etc. And as an important part of my job is to make it easy for other teams to integrate with my services. And today, I'll show you the approaches that we are using and some evolution, how we started, and then what we changed. I'll start with a quote. The integration with your service was the easiest thing I've ever done. Said nobody. Never. Okay, we all know that software integration, usually hard and costly. I think it's the most costly part in software projects, because when you work in your team, it's easy, you communicate, you speak with everybody, you sit together. But when you integrate with other teams, then the fun begins. So we want to make this process as smooth as possible. And there are usually surprises when you're integrating with other services. And we want to minimize them and identify the problems while developing and not in production. That's the key here. We want to do it early in development because the bug in production is much more costly. Okay, so the agenda for today is to understand why testing microservices is more challenging. And when we understand the hard parts, we can see different approaches to test microservices. So why is it more challenging? Or maybe is it more challenging? What are the differences? So let's look back to the time that we had just a monolith. So we had our test, we had our monolith, and all the code is here in this monolith. We could execute the whole test and run the whole code in one go. It was simple. Or maybe it's too simplified, so we had a database, right? So okay, we used an embedded version of this database, or maybe run this database in a container, but still, it's pretty simple. You run your database, you run your service, run your test the whole thing, it works, great, you ship it. But then microservices came to our lives. So we thought maybe authentication is not part of the core domain, so maybe let's extract it to a different microservice. And then we said, okay, maybe emails is also something else, so we'll extract different microservices, maybe billing, etc. So you see where it's going, and if it's not enough that we have a lot of dependencies, each and every one of these dependencies have their own dependencies. So, and in the beginning, you try to work with this, so you run the whole thing on your machine. But the problem that it starts as something nice like this, but when you grow, you have your company grow, you have more users, more developers, more microservices, it looks like this. Okay, and this is just 500 microservices from Netflix and Twitter that they shared their diagram online, so I used it. And it can be much more than 500. I think this diagram's from a few years ago. So, as we can understand, testing microservices is more challenging, but you still want the test that you used to have. You want a short and reliable feedback loop, and you want to test your assumption versus reality, that your tests are really according to the real world. So before we dive in, I want to recap on few tests, which tests, like the types of tests that we are going to use. And to understand it easier, I have this imaginary simplified example. Okay, so let's assume that we are developing a store application. Okay, and there is a basic business flow here. So the user comes to the application with his session that includes the user ID, add item to the cart, click purchase, and then the user should see the confirmation page. But one thing that is important here, the confirmation page should have his name, his full name, like thank you, and the problem is that the store doesn't have this name. This name is here in the user server. It's a different microservice. So let's see how we test it. So there are two types of tests that we are going to talk about them today, end-to-end and integration test. Unit tests are out of the scope today. Unit tests, you test the internal business logic of your service. It's not related to microservices and all of that. So end-to-end test. End-to-end test, you run the whole application the same way you run it in production, and you test the basic business flows. So for example, here the user comes, adds item to the cart, and expect to see the test expect to see the confirmation page that includes the name of the user. Now the problem here, as you can see, this question mark. We don't have the user server because it's developed by a different company, a different team, maybe in different country. So we'll see soon how we can handle this situation. The second type of tests is integration test. So usually you will have this piece of code in your service that communicates with external services. In this example, we'll call it user client. So we don't really care about the whole application here. We care just about this piece of code. And we want to, in this, now it's easier for us to test some edge cases, some abnormal behavior. And we want to test only this. So let's see. Now when we understood what are the challenges, what tests do we want, let's see different approaches to test it. So let's start with the naive approach, which says don't test. But probably you don't want to go there. I mean, if you care about your application, right? Tests are very important to have a quick feedback loop and to not break production. And some developers find some way around it that I want to mention today. They think that they test, but not really. And this is the approach. So they have in their application two implementations of this user's client. One is the real one, and another one is a stub client. And this approach called in-process component test. And while it's a good and valid approach for acceptance tests and etc., it can't replace end-to-end test. And I'll explain why. Then you have something like this in your code. Well, sometimes it's if, sometimes it's some fancy dependency injection that gets the configuration and put the right wiring. But the important thing to understand here is that the real code, is not tested at all. I mean, it is tested in production. So you do want a proper out-of-process component test, end-to-end, what I refer to end-to-end today. And you want it because you want to avoid these embarrassing moments when you're doing just a small change, like this tiny change, and you're sure everything is okay, and you deploy it, and boom, it doesn't work. And you look at the code and say, oh, okay, I know, I missed this like, I don't know, comma here or something. It's a typo. I'll fix it. And you put this comment in your commit, right? Then you deploy again, and guess what? Doesn't work. And you fix it again. You say, okay, now really works. And it might work. Sometimes it works, but sometimes it doesn't. and then usually lose hope, like, and trying to ask someone else to help them. So let's sum this up. In this approach, you don't have end-to-end, you don't have integration, and basically, you don't know if your code works. Like, I worked many years in different companies, and I can say for myself, I will never work in a company that doesn't do automated testing. It's just, I don't know, it looks insane to me now. So let's try to improve it, because we have our store project, a store product, and our boss wants us to ship it, right? And we want tests. So let's think what other approach we can take. So the next thing that we are going to try is to run against an external environment. So basically, our microservice. So basically, we have the production. We have our store and our test, and the test works with the production. This speaks to the external environment, to the production environment. So the good part here that we test that our assumptions are correct. We also ensure the communication protocol and the schema, and we know that it's working. Except one thing that we can test here, which is non-happy flow, non-happy path. Okay, right? So we can test that this service is down or partially down or doing some weird stuff. And while it's good for verifying our assumptions, this approach fails on a short and reliable feedback loop. Running against external environment is unreliable, it has high maintenance cost, and adds complexity to your app. And I will explain why. So first, it's external environment. You use external network calls, which makes the test flaky. Also, it depends on availability of the other system. So if the other system is down because of whatever, you can't now run your tests, which is not good. Also, all the tests between different teams and tests, they have a shared state because there is this external environment, and sometimes it have state, and different tests modify the state, and different teams write different tests, and it might affect each other. And you don't want this, you want isolation. So short state. Next thing is complexity. Many services does side effects on the real world. For example, payments. For example, SMS. And there are much more. So what are you going to do now? Are you going to like pass a parameter? Is test equal true? Are you doing to do, I don't know? So it makes you to add a complexity, add a code just to make this test run. You don't want it. Next problem is security. Probably the service that you're using have some security measures to protect itself. So for example, maybe they throttle the traffic. So when you have a lot of calls from your tests, it might block you. Or maybe show you a CAPTCHA. And as we know, our tests probably can't fill this CAPTCHA. So and then we start to invent things to solve it. Okay, let's have a whitelist. Let's have a parameter. Let's have a secret key that if the other server have the secret key, we allow him. So basically, we start writing code just to make our test run, which is not good. We don't want it. As I mentioned before, it's really hard for us to test non-happy paths. For example, if a user is not active for 1 year, the user moves to another state. Now, it's really hard for us to, like, what do we need to do? We need to create a user, wait 1 year, and just then we can run the test? Or maybe we need to speak with the team that develops these users and tell them, okay, we need you to set up a special user for us that is like 1 year old. So it's really hard to test these non-happy or special cases. Also, maintain the data. So usually this kind of test will require some setup or teardown scripts. And once in a while, this script will break. Then you will have all your tests will break, and you will need to go and start fixing it. Also, you don't want this. Another thing here is that this service needs to be in production for you to work. So if we are starting a new company, I'm developing the store, and another team developing the user server. Now I need to wait for them. I need to sit and wait for them to finish their development, and only then I can start test. It's also not good. So let's sum up this approach. So while it might be tempting in the beginning, because in the beginning it looks really easy, solves your problem, after a while you're using this, you'll probably understand that it's not good enough, and you want something better. Okay, now let's move to the next approach, which is drastically different. And it's using test doubles. But the important part here is that you're using the test doubles over the same protocol that you use in your real system. So you have your microservice, and you use stubs or mocks or fakes behind this same protocol. So if you're not sure, stubs is something that return a canned answer during the test. Mocks is something that you can pre-set up, and they will reply you with what you want. And fakes involves implementing some logic that will use it. The really good blog post by Martin Fowler that explains the differences between stubs, mocks, fakes. I really recommend you to read it if you're not sure about the differences. So let's see how it will look like. So we have our test, we have our store, and we have a fake, let's call it fake user server for this. And the important part here again, that it speaks the same protocol. In this case, I wrote HTTP, but it can be anything else. So let's see how it looks like. So if we have our real service, so we have a lot of we have the API layer, and then we have a lot of stuff, the validation, logic, wiring, etc. In the fake, we'll have the same. We'll have only the API layer, and instead of all what inside, we'll have some stub or mock or fake. And this way, we can run it, and we can use it for our tests. Let's see a code example in Java. Of course, it's oversimplified, but it's to show the point here. So let's do the purchase end-to-end. So first, we set up the fake. We generate random user ID, generate random name, and we set up the fake. In this case, it's a mock. So we say, given a user with this user ID, this is the name. And now this server that we have, this fake, it knows what to reply. Then we act. So we log in as a user, we add item to the cart, and we do the purchase. As a result of the purchase, we get the confirmation page. And now we can assert that the confirmation page contains the name. Okay, as you can see in the small picture there, the store goes to this fake, gets the name, and it all works. Okay, this is the end-to-end. Let's see the integration test, the success example. Okay, so we set up exactly in the same way. We set it up. Now, for the integration test, we want to test the user's client. So we just test this method. For now, we have only one, but we'll do it for any method. And we say, OK, get name for this user ID. We get a result, and we expect the result to be the name. We are doing the assertion, expect the result to be the name. After we have this, we now can test also some failure cases. For example, the user does not exist. So we set up in a similar way. We say given user not found. and we make a call, and we are asserting that we are getting user not found exception from our class. Now, it's important to note here that it's a mock, and we are not sure how the real server behaves, but we assume that, for example, in this case, it returns HTTP 404. But it also might return HTTP 200 with a payload that says the user is not found. So we read the docs and we implement the way we think it should work, but it's not assured. So what do we get here? So we do get a short and reliable feedback loop. Okay, it all works locally, works great. But we implement the test double in the way we assume it works. No, not in the way it works in reality. And the problem with that is that you're going to get something like this. Okay? So these mistakes in code will happen. You can't avoid that. Okay? You know that you build this log 100 times, now you build it the same way, and bam, it doesn't work. And you know what? Even if you know, okay, no, I'm professional, don't have this kind of mistakes, someone in your team will do this mistake. And we, as a development organization, we should avoid, make sure that we avoid these mistakes in production. I mean, it's okay to have this mistake, but if we find it in test, it's okay, no harm made. But if it goes to production, it's not good. And I'll show you this video in a code. So to show this, we are diving into the production code of the store application. This is the purchase method. It gets a user ID, and it gets a list of items. Of course, it's oversimplified, but it will pass the point here. So let's see what this method does. Calculate the price, we get the sum. We have some variable for if built successfully. Then we try to build the user. If if the user paid, we say that it's built successfully. If there is exception, the credit card is stolen, we say build false. Then we render the confirmation page. Okay? And we pass this boolean to the confirmation page. So if we build the user, you will see a nice page. Hey, we build you with this amount. And if we couldn't build the customer, we'll say, hey, we are sorry, we couldn't bill you. Please call our customer service or whatever. So this code is nice, it works. And assume one day your boss comes to you and say, hey, we have a lot of, our store is super successful now, and some hackers trying to abuse it. So they're using stolen credit cards, and we have a lot of rejections. So you know what? Next time somebody uses a stolen credit card, let's block his account. You say, of course, sounds good. Let's do this, let's think. Okay, it's easy, I know how to do this. I'll just add this line here. Okay, users line dot block user. I know that they have this API, I read the documentation, and it's very cool. So I added this line. Now I run my tests. All the tests green. Okay, we can ship it. But the problem here is that the render confirmation page looks like this. The first line here, we are trying to get the name of the user. Now, if we use the test double, we said given user with this user ID and a name. So when we'll get to this line, we'll get the name and everything works. This is green. But the problem is that in production, we can't get a name of a blocked user. So it will explode with the user not found exception. And that's the big under disadvantage of this approach, that we assume one thing and it doesn't necessarily work this way. So now we can add the logic to this fake to say if they called block user, now even if they said given user, you should not return the user. And you start understanding that you're re-implementing the logic of the real thing. And later, I'll show you an approach that allows you not to re-implement this logic. Another disadvantage of this approach is that if there is very central infrastructure service that has a lot of users, now each one of these consumer need to re-implement this. So the store application need to re-implement this fake, and the photographer's product and whatever, all the products need to re-implement this fake. So it's a lot of kind of double work. So to sum up, we are getting partial results on the end-to-end and the integration. So the good part that it's quick and easy. It's also very easy to develop this, and it works, I think, in 90% of the cases. But we could get higher confidence. Another problem with this is that there is no real CI, continuous integration, because if the service provider changes something, as the service consumer, we are not aware of this. So also this, but the main disadvantage of this approach is we can't trust this fake. Okay, so if you try to combine, so it looks like there is something good in approach 1 and something good in approach 2, and 1 plus 2 is 3. So let's try to combine them. Okay, let's try to take the good parts of each one of these approaches, which record and replay tests. Okay, so this means that we will run this one time against an external environment. We will record the requests and the response. And the next time we run the tests, we can run against the recording. So it will remember that for this request, return this response. There are many products that does it in the market. One of them that I use is WireMock. So it looks like this. We have our store application. We have our pre-recorded server, and we run our tests. So it looks really attractive, particularly for small-scale projects, because you record instead of handwriting these fakes, and also you're isolated from external systems. So it looks like it's the best approach. Awesome, right? So, in my opinion, not so. Again, it might be very tempting in the beginning, but let's see what's the disadvantages of this approach. So, first of all, every small change, you need to redo your tests and the recording. So, for example, you add like just one parameter to the API or just one HTTP header. Now you need to do the whole recording again. Remember, this recording is manual, and developers don't like manual stuff. We want everything to be automated. So, of course, if you have 5 tests or 2 tests, it's much easier to record and replay than handwrite these fakes or mocks. But if you have 200 tests, now it's really pain to re-record all this stuff and do the changes. Also, it's a bit hard when you have random data in your requests, because these products, they record the request, and then to this request, they reply with this response. But if you have some random ID or use timestamp, I mean, there are ways to go around to fix it, but it needs to be done manually. So again, it's not only that you record and not only that you need to record every time, but then you need to fix the stuff that is special, the special cases. Also, like in the example before, we don't have continuous integration, so if something is changed, we don't know it. We will know it only the next time we will do the recording again. So again, while many developers lured to this in the beginning because it's so easy, so simple, I do not recommend to go this way. Of course, there is the same disadvantage that we saw before, that if there are many consumers to this one service provider, so each and every one of them need to do this recording and maintain this test suite, so it's a lot of duplicated work. So we want something better. We want a high level of confidence in our tests, and we want a reasonable way to maintain these tests over time. And here I want to talk about test kits. So what is a test kit? In a sentence, it's a lightweight version of the real thing. Okay? Now, what's important to understand here that in this approach, we move the responsibility to the service provider, in our case, the user service, to do this. In the approaches that we saw so far, we are developing the store application, and we choose what we are doing. In this approach, we need the cooperation from the other team. They will provide a test kit for us. So we get a test kit from the users team. We run our store, we run our test, and it works with this test kit. So let's see a code example. So we set up the test. It's in a similar way to the what we saw before, but here we get the opportunity to have a more rich DSL to do it. We can discover which fields we can set. So we don't need to write like if you have 50, for example, we have 50 fields that we care only about 2 of them. In the test doubles approach, we had to now, I don't know, understand what each and every one of these 50 fields means, and put some defaults that I'm not sure which is correct to this. In this approach of the test kit, we put what we care about, which is the user ID and the name in this case, and the test kit provider will fill it with defaults for all the other fields that we don't care about. So we get this builder, we build the user, we set it up, we set given the user. Now we could also work with the regular APIs of registration, but the test kit provider should provide us a helper method to like this given user, because in the normal flow there is a registration form and then a confirmation email and they need to click and etc. So it's really hard. So we are getting the helper method to say, okay, assume that this user is already registered. Now we can do our code, and we do the assertion exactly the same way we did before. The integration test, IT, looks very similar. So we set it up. We are execute the code. We are doing the assertion. Now, for the not found part, for the not found user, we don't even have to set it up, because the test kits already know how to behave when there is no such user. So we just run the code, and we expect to get the exception. Also, we can test special cases. For example, this one. So we can set is active false, and then we say given user, And when we get the name, we expect to get the exception. Now we know that there is also a back office API that should respond to this. We want to test it. So we set it up. We set given user. Again, the user is not active, is blocked. And here we can verify that the back office API does return the user. So we verify that our assumption that the regular API will not return the user and the back office API will return the user, we can verify that it's correct. So after we saw how it works, let's see how you can build one. So remember, now we are looking at from the perspective of the user server, of the server that provides the test kit, not the store, the consumer. So let's understand what is it exactly. So I said before, it's a lightweight of the real thing. And there is this bar between test double on this side and the real thing here. And it's something here, somewhere here. And the point is that you decide where you want to be. Okay, it really depends on the use case, on the situation, on your company, on your culture, on a lot of things. So if this is the real service, you have a lot of parts inside. Let's start to build the test kit. So the API is a must part, because if we don't have the API, it's like there's nothing to do with it. And as I mentioned before, like you remember this point where we had this test double and we failed. So I said, okay, now you're going to implement this logic of blocked user, don't show it. So once you start understanding this, you're saying, okay, instead of this mock or fake here, I want to use the real logic. So you start taking parts from here. So you say, okay, I do want to take the validation part. I also want to take some logic, the logic one, it's the core logic. I also want to take the DAO, but I don't want to require a database here, so I will change it with the in-memory DAO. We'll talk about it very soon. Next thing, there is a time provider. So it depends. If you do not care about the time, you can use the same one. If, for example, I don't know, it's a coupon service that you want to do tests like generate a coupon, and this coupon is valid for 1 week, then go 1 week forward and then test again. You don't want to wait 1 week for this test to run, so you can make another implementation of the time provider. But it really depends on the use case. Of course, all the wiring and the composition will be different because you do change stuff here. You use another DAO. You use just one of the logics. And you have this helper, like we saw before, given user and some other stuff that will help you. For example, go 1 week forward with the time, etc. And for example, we decided logic 2 is internal. It's not relevant to our consumers, so we are not going to include it. In terms of jars, if this is our service jar, this is the test kit jar. There is a dependency from the test kit on this jar. And it's really up to you and how to use to work. Sometimes it's one jar of the service. Sometimes if you have different jars, so you can be dependent only on the stuff that you use. And as let's see what the user gets. So in the end, you have a Java class, which is called user test kit. Usually it have a start method with a port, usually, and a stop method. You have some helper methods, so it really depends on what you need. And here is your opportunity to define like what the rules. Like, for example, update user, you get user update class, and then you say, okay, you can update this, but you can't update the user ID, and then you decide if you can. So The consumer can understand your APIs better. So basically, this is how you do it. This is what you do. Now, an important thing is, what about the next level dependencies? So I'm, as a service provider, have another dependencies, like we saw before, in the database, on other services. And we don't want the other service that use us to have them. So we are not bringing them. Okay? We will cut these dependencies. And the way that we are going to do this is with the technique called integration contract test. Okay? There is another very recommended blog post by Martin Fowler about this. And basically, what we want to behave, that our replacements to the real thing behave the same way. So, for example, we have the user test kit and the user server. Here we have the MySQL DAO. Here we have the in-memory DAO. So we run the same test suite that we run against this MySQL DAO against the in-memory DAO. And this way, we make sure that they behave the same. That when we give the test kit out, it will work exactly the same way as the real server. And an important thing to say about this, that if your architecture is good, so probably it's going to be easy for you. If you're doing something like this, a hexagonal architecture, so you have your domain here, and you have ports for your external stuff, and then you have your adapters, which in our case is the database and the time, and it's all about swappable components. So I think that you should have something like this in any way, not because you want to do a test kit, just because you want a good software architecture. And if you're doing this, so it will be really easy for you to build the test kit, because you just swap these things. Now, let's get back to the integration contract test. We are doing the same. We are using the same technique here to verify that the user server behaves exactly like the user's test kit. And why is that important? Because, okay, now let's think about the store application. When the store application run their tests, they want to be sure that if it works in test, it will work in production. And then can be sure that it will work in production because they know that I have this integration contract test. So there is a really high confidence here that if it works in tests, it also works in production. And that's the key point here. And we used to have, like, the reason that we started to go to this approach of test kits, we used test doubles before. And it happened a lot to me that some developer came to my room and said, hey, you know, this works on my machine. My tests are green, but when I go to production, it doesn't work. Now help me. And then I found myself sitting with him and debugging together to find some stupid, I don't know, mistake, small mistake, really not that important. And it happened too many times. And that's the reason that we moved to this approach at some services. And while using this approach, it almost never happened. So if a consumer service have tests that work, it will work in production in a very high level of confidence. Now, another advantage of test kits, which is not really related to tests, but if you do it, you gain this advantage, that you have a way to communicate with your customers. So now if you change your code, for example, you have some server and you change a validation rule. Now, if somebody violates this rule, the build will break because you're doing continuous integration, and you will both know about it. And then either the consumer services have a bug and they will fix it, or maybe you broke backward compatibility and you need to fix it. But you will know it before it goes to production. And even another advantage of this is that you have the opportunity to run your code in their tests. So as opposed to documentation that gets stale, and even it doesn't get stale, nobody reads it, you can run your code in their tests. So for example, you want to deprecate a method. This method is not going to be used in 1 month from now. So you can write a log in their test. Hey, don't use this method anymore. It's deprecated. And some of them will fix it, some of them not. But then maybe 1 week before you remove this method from production, you just throw an exception. Okay, you do it by implementing your own test kit logic here. So you say, if this method is called, just throw an exception. Then their test will fail, but the production will still work. So it's a really powerful tool it's not related to tests, but it's a real powerful tool to communicate between teams, especially in large organizations. Think about it, it's like so powerful, you can run any code in their tests. You can do whatever you want. Now, in any good thing, there are also disadvantages. So the main disadvantage here, that it requires much more work, much more development. It's not easy. And the second disadvantage is more build dependencies. So now the users of a service that have a test kit are dependent on his implementation, on this service implementation. For example, if this build breaks, now all the builds in the company might break. So you need to be extra cautious with this and not break the builds. Also, it adds like more time to every change. It builds a lot of builds, but that's what you want. You want continuous integration. You want for every change, all the other your consumers will know about it. So yeah, in this approach, we are getting end-to-end. We get integration. We have high confidence. It's easy to maintain. Let's sum up all the approaches that we saw today. So the first one, not testing, it's not really acceptable, right? External environment, it might be tempting in the beginning, it will work, but for the long run, I do not recommend this. Test doubles, it's an approach that we use a lot at Wix for most of the tests, I think. Record and replay, again, I think it's really tempting in the beginning, but I discourage you to use it. And test kits, which is something that we use in Wix for especially infrastructure services. So these are the two that we at Wix use most of the time. Of course, I'm not saying like it depends on your company, on the stuff that you're doing, but this is what works for us for a really big organization. And I have this question that what should I use, which one? So it really depends on so many things, a lot of things, but a general rule of thumb is this. Usually I look on the number of consumers and the complexity of the API. So if the complexity is low and there are no many consumers, so just do the test doubles, it's easy, it works, it's good enough. Also depends, like if you have the same team developing a few microservices that communicate between them, so it's good enough, the test doubles, because you know on every change the communication is good. Once the API complexity gets higher or the number of consumers get higher, I think test kits have the advantage here. So the work that needs to be done to make test kits getting paid off when it's high. And that's all. If you enjoyed the talk, I'll be happy to get your rating and your comments. And we'll have some time for questions now. Yes. Wait, do we have a microphone here? Okay. Okay, so the question was if you change your API but you forget to test your test kit. I'll try to. Let me. Okay. So this one. Yeah, you got the microphone.
Previous slide. It's like integration test.
Which one?
Yeah, this one. Oh. So you see there is a rectangle in the middle. It's black. It communicates to database. It's the second line. What if its API changes, but the people who support test kit in that rectangle, they forget to update test kit? How do you check that?
So the answer to this will be the integration contract test. So similar to this, this is a database, but you're talking about another service, so it's the same. I have the client, I have my fake client, and once they change this, I will know because it will break.
But how is it working? I mean, is it calling the same method? Is it giving some special inputs? So MySQL DAO changed, but in-memory DAO didn't.
Yes.
How integration tests understand
you don't care
that?
about if it changed and the same and the tests are green, you don't care about it, right? Because your service doesn't use it's your internal implementation. If this changed and the test red, so you need to fix it and to make the test. Okay.
Thank you.
More questions?
I didn't get a point about test kit. Do we have one test kit per one microservice or one test kit per like several microservices? So test kit combines several.
Yeah, one test kit per one microservice.
So don't we need to solve the issue how these test kits are communicate between each other?
So they're not communicating between each other because we do not call the next level dependencies like we saw here again.
So for example, if we have 3 microservices, not 2, so we need to...
if the store uses 2 microservices, so you use 2 test kits, yes.
And if we have 3 microservices, so we have 3 test kits. So these 3 test kits like communicate with each other, right?
It depends. Most of the time not, but in some cases they do need to communicate with each other. Others, but it's like really depends on the situation and the use case. If you want, let's talk about this later. I think there was a question here.
So in one of the slides you mentioned that you stop with the test kit and don't go further for other transitive services. My question is why? Why not have, like we have in the hexagon, all of the logical parts talking to one another in memory, and then you have reliable testing, and it's also fast. So maybe you don't have like the HTTP errors, but you still have...
So I think it's similar to the other question. So it really depends, and when we try to do it, like the problem that you could get an infinite level of dependencies, which is usually unnecessary. So if each test kit uses another test kit, we did it in few places, we find out that it adds a lot of complexity, it's hard to maintain, and it's like, because it can be like very long chain of test kits. And also you don't want the dependency, like you don't want the CI dependencies on all the other test kits. So for example, your service use the store service use the user service, which use the security service. You don't want to be dependent on the security service. Yes, there is a question there.
Thank you so much for your speech. It was quite interesting. And there is a question that I have. At the very beginning, you said that if you need to test some corner case, against a production environment, like you have to go to this team and ask them to introduce some new user and things like this, but with test kits, you actually have to go to this team and ask them double their development work for you.
Okay, so as I said, test kits is a different approach, so you need a cooperation between the teams. And once the team of the users, they decide to do it, so they do it once and it works for all the teams. For production environment, now every team need to call them and say, okay, set up this special user for me. Oh, did I answer your question?
Yeah, but so let's say...
And it works in test and not in production.
It works if you have all the teams working together. But, well, I'm happy to know that that is the case for Wix.
What?
It's far from, you know, most companies' reality.
Also, yeah, if you want to talk about, like, come to me later and we can
yeah.
discuss. Yeah. Okay, sure. More questions? Anyone? Okay, thank you very much for coming. I'll hang around here, and if you have more questions, I'll be happy to talk to you after.